Okay, so let's start another project besides the one that I was already working on. So that when I want to program, when I want to code, I have the choice. I have the choice between those two projects. I don't always have to work on the same one. Okay, so this is going to be some simple 2D ray tracing, and I got the inspiration from a guy on YouTube who did this on Vim like a few weeks ago. I'm gonna put his channel in the description. And I mean, as a matter of fact, I got inspired to learn the SDL2 library because of him. And so yeah, so I've looked like at I've watched half of this his video, but I don't have the code in my mind. Like I know the principles behind ray tracing, but I will not be copying his code. I'll be coming up with it on my own, and actually I'll be using a renderer because if I'm not mistaken, he used the surface in his video. So it will be another way of doing it. I'll use lines instead of individual pixels with rectangles. So yeah, so let's begin. I'll try to keep I'll try to split this series into several different kind of short videos, like maybe 20 to 30 minutes max per video. And so in this first video, we're gonna create our window. So let's open Paint. So here we're just gonna try to get our window running, and we're gonna just try to define a light source, which is going to be basically a disk with a certain color. And yeah, if we can just have the light source and then have it move with the cursor, our mouse cursors, and I think that's pretty good and can be achieved in less than 20 to 30 minutes. So let's start, and if there's a little bit of time left, we're gonna do the obstacles, because at some point we're gonna place obstacles on the scene. And so we could, if we have time, we're gonna create a class for obstacles. All right, so let's start. So I'm just going to write the basic code for SDL2 in order to set it up. So this is just the usual include IO stream and include SDL2. Now I'm going to create my main function. I have to put in the argument count and the argument text. So char argv. Right, and so it's going to return 0. And there we go. So let's just make sure that it runs. It does. Good. Okay. So now what we're going to do is we're going to create a window and renderer. I just learned about this. I just checked it out before recording. So if we have our window and renderer set as null, then we can just pass them inside this function and they will have their value. So, and this, in case of an error, this gives us -1. So let's just do SDL window equal to, so window is equal to null pointer, and SDL renderer is equal to null pointer as well. And so if SDL create window and render of so let's define our width here. Define the window width 800, defined window height 800. So window width here, window height. So the flags, what flags do we have? The flags used to create a window, SDL create window. So let's see the flags here. SDL flags, SDL window shown. So I think it can just be 0 here, no problems. Let me just lower a little bit the sound of the music. It's a bit too loud. Okay. And so what else does it need? So the window and the render. Right. So this doesn't work because because maybe it wants the address. That's the pointer itself, which I think is a little bit weird. How does this work? A pointer filled with the window or null on error. Okay, but why is it a double pointer? Okay, let's see how it works. So if this is equal to -1, then there was an error. So fail error creating window and renderer, and let's just do SDL destroy window and SDL destroy renderer SDL quit and return 1. Or actually, you know what, let's just do yeah, okay, let's just do this. Okay, so what does this do? Yeah, so it created our window. Okay, good. Now let's see. What if we do, so it opened our window for a short second. So now let's just do our window logic to keep it open. So let's create a boolean is running equal to true, and while it's running, let's just do create an event. So SDL event, and then let's pull the events. So let's check for every event, and here if event type is SDL quit, then we're gonna set our it's running boolean to false to get out of the loop. And so here I'm just going to add basically exactly this. I can create a short function for this. Void end program, and basically it's just going to do like, so it's just going to take SDL window SDL renderer, oops, renderer, and basically it's just going to take this. Okay, end program, and so window renderer, and same thing here. Let's just put this here. Okay, so what does this say? It can be made static. Sure, let's make it static. Okay, so let's see, does this run now? So this does run, so we do get our window, and we can close it this way, no issues here. Okay, good. So now let's create our circle. So let's just see if everything is good. Create a first rectangle, give it coordinates 100 100 and like 300 of thickness, 200 of height, and here each time we iterate through the window, we're first going to clear or I think it's render clear. We're just going to clear the window, but before that we need to set the render draw color to black, because we want our background to be black. So let's do that here. Right. So this will set the draw color to black, and then it's going to clear the window with this color. And now, after handling the events, we're just going to draw our rectangle in white. So let's just do set render draw color to render, and here we'll just make it white. So 0xFF, FF, ff here, and here we're just going to SDL render fill rect renderer, and the rectangle, let's take it here. And here we need to do SDL render present, just to update it at the end of each while iteration. So if we do this, we should just get a white rectangle here. Good, so everything's fine. I'll just remove this for now, and I can also remove this for now. And so render objects on screen. So this is where we are going to render the objects on the screen. When we first enter this while loop, we're first going to clear the screen, then we're going to handle the events, and then we are going to handle the object, to render the objects on the screen. So if we have to change coordinates on whatever, we are going to change coordinates of certain objects. We're going to change them in here. If their coordinates are meant to be dependent on like user input. So for example, my mouse position or keyboard inputs. And yeah, this is where we're going to render objects on the screen, and this will just actually update the graphic output. Okay, so now let's create our class for a light source. So we are just going to call it a light source. It's just pretty explicit. So let's just call it light source. What is it going to take as private attributes? Let's give it a position, X and Y. Let's give it a radius. And maybe also a color. So for the color, actually let's just do this way. And for the color, let's do, so a color has 4 channels in SDL2. It has RGB and alpha, as you can see in the text here, RGB and alpha. So we are going to give 4 different attributes here for the colors. So unsigned int of 8 bits, R for red, same for green, and oops, that's not how I should do it. Here. So we're going to have 4 different attributes. And now, what is our constructor going to take? Let's see. Light source is going to take in X and Y, because when we create our light source, we want it to have a starting position. So int X init, int Y init, and a double R for the radius. Let's do RD init for the radius. Okay, now the color is just going to be white, I think, from the beginning. So by default, the color is going to be white, and then we're going to have a setter to change the color. So let's do X will be X init, initialize it to X init. Y, and let's initialize it to Y init. The radius, let's initialize it to RD init. And then R is going to be initialized to, we're going to make everything white. So 0xff, 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 and a 0xff. Right. So this seems good to me. This looks good to me. So let's just right now real quick do our set color method, which is going to take several const 8 parameters, arguments. So new R, new G, new B, and new B. This kind of sounds like a Chinese expression, new B. Okay, well, kind of also like a new R. Okay, well, I don't know why I'm saying that. So light source set color, let's just define it here. We declare it, let's not make it inline because otherwise it's going to be a bit of a mess within the class. So here it's just going to be r equal to new r, g equal to new g, right? B equal to new b, and a equal to new a. This is all that it's going to do. Now let's see. Let's make a method to render it. So render fill, because I'm saying fill so that maybe we can have, I'm leaving space to have two methods, one render draw and one render fill. And so fill is going to like actually fill it, like when it draws, like it's going to fill it with a color. So if it's black or red, if it's red, it's going to just draw it as a red disk. And if it's empty, I mean, if it's render draw, it's just going to draw the circle. But in this video, I think I'll just do render fill and I'll do render draw later. So what is it going to take? It's going to take STL renderer, because we are going to draw it on the renderer, and nothing else. I think that should be it. So let's do it here. Light source render fill. And so let's see. Oops, didn't mean to do that. So how are we going to draw our circle? Well, in order to draw a circle, I have my own idea, but basically we have the radius. So we have information about our radius. So what we're going to do is, if we could look at the radius, so if we have the x and y axis this way, so x and y here, or rather, let's be more precise, in the case of programming a window here, x goes this way and y goes this way. By that I mean that if you look at the window, basically x coordinates go this way and y coordinates increase as you go down. And so let's represent it this way. And so my idea is that if we have our circle, our disk, and we have the radius, so this is the radius, but this is also the radius in terms of y coordinates. So let's look at the box that this forms, the shapes that this forms, and then let's just draw a quarter of our disk. So basically we're just going to draw this part, this part here. This is going to be the quarter of our disk, and then by symmetry we should be able to easily draw the rest of the disk that is here. And so the condition, I mean, how we're going to draw this first quarter, we're just going to use the Pythagorean theorem to check that we're going to iterate through all the pixels in this square, but if the pixel that we're iterating through, like that we're looking at, is here, that means that the distance between this pixel and the center of the disk here is greater than this than the square root of this plus this, like this plus this. So this is the radius, and this should be like the distance actually, and so this is the x value, y, and so this is just a right rectangle, triangle, and so it's just a theorem. Okay, so let's do this. So let's create a rectangle for our pixel, and pixel here, and so let's just initialize it to like -1, -1. Okay. Now for int I equal to 0, I below well, it's a rectangle, so we should give it a certain thickness. So this is going to be its thickness in terms of x, and here it's height. Okay, so I below radius, and then we're going to increment I each time, and we're going to do the same for j. J below radius, and j plus plus each time. And so here, oops, what we're going to do is simply we're going to say that we're going to check the condition. So if, so here we're going to have to import math, because we're going to use square root and whatever. So here it's just going to be our formula. If the square root of let's see, of so the power of I, so I squared plus j squared, oops, j squared, let's see, is let's just do it this way. Okay, boom. If this is below or equal to the radius, then we're going to draw the pixel. So we're going to say that the pixel is equal to so x plus I, y plus j, 1, 1, and then we're going to draw it. So SDL render draw or render fill rect, and render, and here pixel. And so we're just going to repeat the process a certain amount of times, so 4 times, because we're so we drew the point that is let's just come back. We drew the point that is here, so by symmetry we're just going to draw the ones that's here, here, and here as well. And so 4 times. So the first time will be the ones that we just drew. Second time, let's draw the ones that's on the bottom left here. So basically we just take x and subtract I instead. Then let's do the one on the top left here. So basically we still subtract I, but we also subtract j. And for the last one, top right, so we add I, but we subtract j. And so if I do this, it should work, but I think I forgot something. We should here set render draw color to so the colors of our light source. Right. So I think if I do this, it's gonna work. Let's just create here our object. So light source 1, and let's make it so we have int x. So we have to do, like, for example, 100, 130. And now let's do here. Let's render it here. So ls1.render fill render. So if I run this, does it work? So it does. Nice. So we have our circle here. It looks pretty neat. Now let's check if the color change works. Set color. Let's do it, make it red. Okay. So if I do this, does it work? Right. So it does make it red. That's good. Everything works. And now let's do it so that it moves. It follows my cursor, because since we're doing ray tracing, at some point we're going to want to move our light source within the window, and there will be many obstacles, and we will just want to see how the shadow cast moves depending on, like, the position of the circle. So here let's do so let's add a move method, and so let's say this is going to be a const new x, and const, so int new x, const int new y, simple as that. And let's write here. So LightSource, and let's see. What we're going to do is just set x is going to be equal to new x, and y is going to be equal to new y. I think that's all there is to it. I think so, yes. So now let's handle it inside the events. Let's call the function within the events. So we have to check for mouse motion, basically, when the mouse moves. So here, if we look at the API, we have SDL. So we are in the category render, so that's why it doesn't work. Complete API index, and here if we look at this mouse motion event, when we move that's when we are moving the mouse. So we have a type SDL mouse motion. So if the type of our event is so SDL mouse motion, then what we're going to do is so we're going to retrieve the position of our mouse. So this should be, if I remember correctly, there's one, but let's just type mouse, or let's see, maybe get mouse state seems good. And okay, yeah, so it takes the pointers and directly modifies the values of x and y. Right, so here what we're going to do, so there are integers, so let's do x, so int mouse x and mouse y, and here let's do SDL get mouse state x state and address of x and address of y. Oops, that should be mouse x, and here mouse y. And so here we're just going to do LightSource 1 move to x, mouse x and mouse y. So this should move it to our cursor, right? So it does. When we get out, it stops here. Fair enough. But it does follow the cursor. Good. Now let's only make it follow when we are left clicking on the window. So to do this, let's look at the API index. So we have mouse here. That's not what we're looking for. Mouse button event sounds good. Type, let's do so mouse button down. Mouse button index. So we have a mouse button index here. So I'm guessing left click would be index 1, right click index 2, and whatever. So should we just do button down in general? Let's try this. So here in our condition, let's just add event dot type is equal to SDL mouse button down. Let's see, does this work or not? Right, so this doesn't work. Let's see. Yeah, I think it doesn't work because the type cannot be this and this at the same time. Let's see, how can I do this? Maybe if I do event button is equal to 1. So this would be left click, I suppose. Right, so this works. I'm not sure why this works and not the other way. Alright, so I think maybe I know. It's because, yes, the event type cannot be several different things. Like the event type has to be one thing. So here it's mouse motion, and we are checking here with a condition that it is mouse motion. So we cannot have another condition with event type here. But if we have a mouse motion and at the same time we left click, it will still change event button dot button. Maybe it will not change the type. or maybe it will, I don't know, but event button will be changed because it will not overwrite what a mouse motion changes in the event, if that makes sense. All right, so I'm going to stop the video here. I think it's a good start already, 30 minutes. And so, so yeah, oh, it actually follows through, like even outside the window. So that's pretty funny. All right, so let's stop here, and let's continue another time.